A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You ever get the feeling that we have reached the end of the internet, Herman? I do not mean the end of the content, because there is plenty of that, but the end of the usable, high-quality stuff that actually makes these models smart. It feels like we have mined all the gold, and now we are just sifting through the dirt.
You are hitting on the literal crisis of our current moment, corn. It is called the data wall. For the last few years, we have been acting like human language is an infinite resource, but it turns out there is only so much high-quality text that humans have actually written and put online. We have exhausted the libraries, the forums, the research papers, and the high-quality code repositories. As of today, March 23, 2026, we are staring at a world where the supply of fresh, human-curated data is essentially flatlining.
Well, today's prompt from Daniel is about how we stop hitting that wall and start building a ladder over it. He is asking us about the evolution of synthetic data, specifically how large language models are being used to generate their own training material, and how that helps us dodge the massive headache of personally identifiable information, or PII.
It is a timely one from Daniel because, as of this month, the shift has become absolute. We are no longer in the experimental phase. Gartner just put out a report saying that 75% of all enterprise artificial intelligence training data will be synthetic by the end of this year. We have moved from a world where synthetic data was a niche research curiosity to a world where it is the primary infrastructure for the entire industry. If you are not using synthetic data in 2026, you are basically trying to build a skyscraper out of hand-carved stone while everyone else is using precast steel.
75% is a staggering number when you consider that just a couple of years ago, people were still arguing about whether synthetic data was even real or just a high-tech hallucination. It sounds like the industry has collectively decided that if the humans are not writing enough, the machines will have to pick up the slack. But before we get into the heavy technical weeds, I want to talk about this privacy angle Daniel mentioned. Why is synthetic data such a game changer for things like healthcare or finance, where you cannot just go around sharing people's records?
To understand that, you have to look at what we used to do, which was data masking or anonymization. We actually touched on the risks of this back in episode 1234, Digital Plutonium, where we talked about how dangerous handling real PII can be. If you had a database of patient records and you wanted to use it for research, you would go in and scrub the names, change the dates of birth slightly, or blur the addresses. The problem is that traditional masking is incredibly destructive. You end up losing 30 to 50% of the analytical utility because you are literally breaking the connections in the data to protect the people.
It is like trying to study a map where someone has erased all the street names and moved the landmarks around to protect the residents. You can see there is a city there, but you cannot actually navigate it.
That is a perfect way to put it. But with synthetic data generated by a model like GPT 5.4, which just dropped on March 6th, we are not masking the old map. We are creating a brand new map of a fictional city that has the exact same traffic patterns, population density, and infrastructure as the real one, but where no one actually lives. In technical terms, the large language model learns the underlying statistical distribution of the real data. It understands the complex relationships between variables without ever needing to store the specific identity of a person.
So, if I am a researcher looking at a rare heart condition, I am not looking at a masked version of John Doe's record. I am looking at a completely synthetic twin that has the same medical markers and outcomes, but John Doe does not exist in this dataset.
And the utility retention is the headline here. Recent industry analysis from CX Today, published on March 18th, shows that these synthetic datasets are now hitting 85 to 95% utility compared to real-world data. In some specialized cases, it is as high as 99%. You get all the insights with none of the regulatory risk, and that risk is massive now. As we sit here in March 2026, privacy laws cover 79% of the global population. The European Union AI Act is coming into full effect this August, and it is going to require strict audits of where your training data came from. Synthetic data is basically the only safe harbor left for developers who want to move fast without getting crushed by compliance.
It is interesting how the regulation is actually driving the technology forward here. Usually it is the other way around, but if we are talking about utility, I am curious about the how. Daniel mentioned other use cases where these models excel. I saw that NVIDIA just announced something called the Physical AI Data Factory Blueprint on March 16th. That sounds like something you would have a poster of on your wall, Herman. What is actually happening there?
It is a massive shift in how we think about data. NVIDIA is using their Cosmos Foundation models to generate synthetic data for the physical world. Think about autonomous vehicles or industrial robots. If you want a self-driving car to be safe, it needs to know what to do when a sensor fails during a blinding blizzard while a deer jumps into the road. How many times does that actually happen in real life while you have a test car recording? Almost never. It is a long-tail edge case.
Right. And you cannot exactly go out and wait for a blizzard and a deer to appear at the same time, just to get your training data. You would be waiting forever, and it would be dangerous to boot.
You would. So instead, you use the physical AI data factory to simulate it. But this is not just a video game simulation. These models are physically accurate. They understand the way light bounces off snow, the way friction changes on an icy road, and how a specific camera sensor might glitch under those conditions. They are generating millions of these rare scenarios so the AI can experience them before it ever hits the pavement. They are even integrating this with their GR000T models for humanoid robots. It is about creating a curriculum for the physical world that is impossible to capture manually.
It is basically giving the AI a dream world where it can crash 1,000,000 times, so it never crashes once in the real world. That makes sense for robots, but what about the GPT 5.4 engine Daniel mentioned? OpenAI is saying it has an agent-driven synthetic data engine. That sounds a bit more abstract.
It is about moving from static data to reasoned data. Older synthetic data was just about copying patterns. The new agent-driven engines in GPT 5.4 actually use a chain of thought process to generate data. If you ask it to generate 1,000 synthetic legal contracts, it does not just look at what a contract looks like. It acts as a synthetic lawyer, thinking through the clauses, the jurisdictions, and the potential loopholes. The result is a data set that is not just statistically similar to real contracts, but logically sound. This is huge for training smaller models.
You are talking about model distillation, right? Where we use the big, expensive frontier models to teach the smaller, more efficient ones.
That is one of the most practical use cases right now. We call them synthetic textbooks. If you want to train a small language model to be an expert in organic chemistry, you do not just feed it the whole internet, which is full of junk, memes, and misinformation. You have a model like GPT 5.4, write 100,000 pages of the most perfect, clear, and accurate chemistry textbooks imaginable. Then you train your small model on that gold data. It ends up being smarter than a model 10 times its size that was trained on the messy, real-world internet.
I like that. It is like homeschooling your AI with the best tutors in the world instead of just letting it hang out on Reddit and hoping it learns something useful. But Herman, we have to talk about the catch. There is always a catch. I have been hearing this term Habsburg AI or model collapse. If we are just feeding the machines their own output, aren't we going to end up with some kind of digital inbreeding?
That is the primary technical debate in the field right now. Ilya Shumailov, who is a brilliant researcher from Oxford and Cambridge, has done the foundational work on this. The theory is that if a model is trained primarily on its own synthetic output, it starts to lose the variance of the real world. It focuses on the most likely patterns and starts to ignore the rare but important ones. Over time, the model's reality narrows until it eventually starts producing gibberish. It is a feedback loop of degradation.
Like a photocopy of a photocopy. Eventually, you cannot read the text anymore because the errors amplify each other.
That was the fear. But there was a major breakthrough published for the ICLR 2026 conference just a few weeks ago on March 5th. Researchers demonstrated what they call the accumulate strategy. They found that as long as you keep a core of real-world human data and mix the synthetic data in at specific ratios, you can actually prevent the collapse. You are not replacing the human data, you are augmenting it. It is like adding vitamins to a diet. You still need the calories from the real food, the human creativity and nuance, but the synthetic supplements allow you to grow much larger and faster than you could otherwise.
So it is not a total replacement. We still need the humans to say something original once in a while just to keep the machines grounded. That is a bit of a relief for my ego, I suppose. But what about the governance side? I saw a warning from Gartner that 50% of AI agent failures this year will be caused by poor synthetic data governance. That sounds like a management nightmare.
It is a massive risk, and it ties into what we discussed in episode 1235 about securing the agentic AI stack. We are seeing governance sprawl. When you are generating billions of rows of synthetic data, you have to be incredibly careful about version control and data poisoning. If you accidentally train a model on a synthetic dataset that has a subtle bias or a factual error that was hallucinated by the generator, that error gets baked into the new model's brain. And because it is synthetic, it is much harder to audit than human data. You cannot just go back and ask the person who wrote it why they said that.
It is the ultimate garbage in, garbage out scenario, except the garbage is now being produced at industrial scale by an automated factory.
And that is why the National Institute of Standards and Technology, or NIST, just launched the AI Agent Standards Initiative on February 17th. They are trying to create benchmarks for how we validate synthetic data. We need tools that can prove a synthetic dataset is a faithful representation of reality before we let it near a production model. Companies like Gretel.ai and Tonic.ai are leading the way here. As of February, Tonic.ai holds about 17.7% of the mind share in this space, with Gretel at 12.1%. They are not just generating data, they are providing the privacy scores and utility metrics that prove the data is safe to use.
I want to circle back to something Daniel brought up, which is the cold start problem. This seems like a big deal for startups or anyone trying to launch something brand new. If you are building an AI for a product that does not exist yet, you have zero user data. How does synthetic data help you get off the ground on day one?
This is where synthetic data is a total equalizer. In the old days, the big tech companies had a massive advantage because they already had all the data. If you were a startup, you had to wait months or years to collect enough user interactions to make your AI useful. Now, you can use a frontier model to simulate 1 million ideal user interactions. You can generate a synthetic history of how people might use your app, what problems they might have, and how the AI should respond. You can deploy a functional, highly tuned AI on the very first day your first real user signs up. You are essentially manufacturing the experience you haven't had yet.
It levels the playing field. You don't need to be a giant to have a giant's dataset. But I wonder, as we move toward the end of 2026, do you think we will ever reach a point where we don't need human data at all? Could an AI just sit in a room and think its way to intelligence by generating and learning from its own synthetic logic?
That is the AlphaGo dream, right? AlphaGo Zero learned to play Go better than any human just by playing against itself. But the physical world and human language are much more complex than a game of Go. Go has fixed rules. Language is a moving target. I suspect we will always need a human signal to keep the AI relevant to our actual lives. The real future is not human versus synthetic. It is the hybrid approach. We use the human data for the soul and the context of the model, and we use the synthetic data for the scale and the robustness.
I like that. The human data is the spark, and the synthetic data is the fuel. It keeps the fire burning without us having to constantly chop down more trees. But we have to stay vigilant. I am thinking about those provenance audits for the EU AI Act. If you are an enterprise architect listening to this, what is the one thing you should be doing right now to make sure you are not walking into a legal buzzsaw in August?
You have to prioritize a data provenance audit immediately. You need to know exactly which parts of your training pipeline are human, which are synthetic, and where that synthetic data came from. If you are using a third-party provider, you need to see their mathematical privacy guarantees. The days of just scraping data and hoping for the best are over. You have to be able to prove that you didn't just mask PIII, but that you actually moved to a synthetic model that respects the rights of the individuals. And remember, the accumulate strategy, never train exclusively on synthetic data. Keep that human core.
It sounds like the move fast and break things era has been replaced by the move fast and simulate things era. It is a more careful kind of speed.
It is, and it is also a more creative one. We are seeing people use synthetic data for things we never imagined, like simulating rare weather patterns for climate change research or generating synthetic voices for people who have lost theirs to disease. When you stop looking at data as something you have to find and start looking at it as something you can design, the possibilities open up.
It is a powerful shift. We have covered a lot of ground today, from the data wall to the Habsburg AI risk and the rise of these specialized physical data factories. It is clear that synthetic data is not just a workaround for privacy. It is becoming the primary way we build intelligence. It is the ladder over the wall.
It is the new foundation. We are building a digital world that is as rich and complex as the physical one, and synthetic data is the brick and mortar. But as we've seen with the NIST initiative and the warnings from researchers like Shumailov, we have to be the architects, not just the bystanders.
Well, I think that is a good place to wrap this one up. We have given the listeners plenty to chew on. Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show. We literally couldn't do this without that serverless compute.
This has been My Weird Prompts. If you are finding these deep dives useful, do us a favor and leave a review on your podcast app. It really does help other people find the show and keeps us going.
Find us at myweirdprompts.com for the full archive and all the ways to subscribe.
Catch you in the next one.
See you then.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show.